Alright, good morning everyone. This is classwork 20. We are in week 8 and our objective is that students will be able to solve continuous compound interest equations using the natural logarithm. Okay, so make sure you've watched classworks 19 and 18 before this one because they're going to build off each other. Okay, so you're due now, and I want you to pause the video, take a second to do this on your own, is to solve the following equation for t. 3000 equals 2050 e to the 0.05 times t. So pause the video, and hopefully you've completed this by now. This was a problem exactly like the ones we were doing in classwork 19. So to solve this equation for t, step number 1 is to isolate the exponent. This is my exponent, e to the 0.05 times t. Then, in order to isolate that exponent, I'm going to divide both sides by 2050. So when I divide both sides by 2050, we're going to take out my calculator and I'm going to put it to the side, 3000 divided by 2050 equals 1.46, I'm going to round here, e to the 0.05 t times t. Okay, now I can take the natural logarithm of both sides. And remember, if you need a refresher here, go back to lesson number 19, okay? Because I'm going to then use properties of logarithms, which we've gone over in a couple lessons, times the ln of e. And what's the ln of e going to be equal to? That's an identity. The ln of e is 1, okay? So I've got the natural log of 1.46 equals 0.05 times t. And then I'm going to isolate my variable. So to get my variable all alone, I got to divide by 0.05. And I'll do the ln of 1.46, so that's still in my calculator. I'm going to hit the ln button and then divide. So I've got t equals 0.38 divided by 0.05. So I'm going to divide this by 0.05. And I get t equals approximately 7.62 if I round to 2 decimal places. Okay, so if you need a refresher, go back to classwork 19 for that, because what we're doing today is going to need to use this process. So this is just like classwork 18 where we had word problems, and if you remember in classwork 18 we were using our first two growth and interest formulas. We used f equals p times 1 plus r to the t, and we used f equals p times 1 plus r over n to the n times t. Now, we did not use our continuous compound interest formula, which is f equals pe to the rt, or PERT, right? This is for continuous compound interest. So if I ever see continuous compounding, that's when I know I need to use this formula. PERT is for continuous compounding. So if we read example number 1, Phyllis deposits $3,000 into a retirement account that has a 6% interest rate that is compounded continuously. How many years will it take for Phyllis to have $5,000? So we've got a couple things going on here. We want to figure out how many years will it take for Phyllis to have $5,000. And we know we have the key word here, compounded continuously. That tells us that we're going to be using this formula, the PERT formula, okay? Now let's circle our other numbers. We've got a 6% interest rate. We deposit $3,000, or Phyllis deposits $3,000. And we want to know how many years will it take for her to have $5,000. So years, what variable is years? So if we remember the PERT formula, and if you need to, go back to classwork 16, I think, is when we did this. Years is always time, right? T. So years is T, so we won't know T. We need to solve for T. If we deposit $3,000 initially, right, our initial deposit or our original value, our starting value, that's P. Our percent interest is always the rate, right? And then what do we have to do with rate? Anyone remember? Rate is always the percentage divided by 100. So if I do 6 divided by 100, I get 0.06. Okay, so our rate's going to be 0.06 instead of just 6. Okay, and then I've got this $5,000. We're thinking that's the ending value, right? The final value, that's my F. So if I substitute all these numbers into my formula, my F is 5,000. My P is 3,000. E is just E, right? And then my rate, 0.06 times T. And now we have an equation, just like what we were doing in the last lesson, that we can solve using our steps and using the natural logarithm. So my first step is to isolate the exponent. So I need to divide both sides by what? If you said 3,000, you're correct. So let me see, what is 5,000 divided by 3,000? We get 1.666. So I'm going to say 1.67 to round it equals e to the 0.06 t. What's my next step? I'm going to take the natural logarithm of both sides. Good. So I have the ln of 1.67 equals the ln of e to the 0.06 t. Just like the last lesson. Okay? Now what? Properties of logarithms, right? So I'm going to rewrite this. I've got the ln of 1.67 equals the natural log, but we're going to use our properties, right? So we're going to bring to the front our exponent. Bring that to the front, 0.06 times t times the ln of e. And what is the ln of e? 1, right? So we have ln of 1.67 equals 0.06 times t times 1 is invisible. Then I can solve for t. So t equals the natural log of 1.67. And how do I get t by itself? I have to eliminate this 0.06. What would I do? I divide both sides by 0.06. Good. So my t will be the natural log of 1.67 divided by 0.06. So let's do that. The natural log of this, I've already got 1.67 in my calculator, and I hit my natural log button, is 0.51 divided by 0.06. And my t equals 8.51 years would be the units here. 8.51 years. Now, in the classwork, you don't need to put the units because it's easier for me, or the key is not going to have the units, but it's important to know what the units are, okay? So if it's t is years. So it would take 8.5 years for Phyllis to get $5,000 in her her retirement account. Okay? So it's very similar to lesson 18, but now we're just using the natural logarithm instead of the common logarithm. All right, let's go to number 2. Stanley currently has $13,922 in his retirement savings account. He initially deposited $4,520 into the account 15 years ago. What is the interest rate in Stanley's retirement savings account? Okay, so let's underline the question. What is the interest rate? So interest rate is which variable? R. So we know we're going to be solving for R. And here it doesn't say so because I wrote this question, but we are going to assume continuous compounded. Because that's what we're practicing. So that's my fault. I forgot to write that into the problem, but we are going to assume this is continuous compound interest, okay? Because we're practicing with the natural logarithm in our e values. So we will be using f equals p e to the rt. Okay? Let's circle our other numbers. What else do we have? He currently has $13,922. He initially deposited $4,520, and that was 15 years ago. So, F is my final value, P is my initial value, R is my rate, and T is my time. So to me it looks like if we have initial deposit of $4,520, that's going to be P, right? Initial deposit. Then if we currently have $13,000, that's going to be the final value. And if it was 15 years, that's going to be my time. So I'm going to substitute all those values into my equation, and I'll get 13,922 equals 4,520 e to the r times 15. And we don't know what r is. That's what we're trying to find. So now I'm going to use my steps. I know exactly how to solve this. I'm going to isolate my exponent, which, how do I do that? Going to divide both sides by 4,520. Okay, so then let me do that in my calculator. 13922 divided by 4,520 is going to give me 3.08, and that's still equal to e to the r times 15. What's my next step? I'm going to take the natural logarithm of both sides. And now what? Properties of logarithms. Good. So, what property am I going to use here? When I have a power or an exponent, we slide that to the front. R times 15 times the natural log of e. And what's the natural log of e? 1. Good. So I'll have the natural log of 3.08 equals just r times 15. Now we're on step 4. What's step 4? Isolate the variable. So how am I going to get r by itself? I'm going to divide both sides by 15. Perfect. So r is going to be equal to the natural log of 3.05 all over 15. So let's calculate that natural log here and divide. So we get 1.125 divided by 15. And our r is looking like 0.0749. So we're going to say r is 0.075. If this asked for a percentage, it doesn't, but if we wanted this to be a percentage, that would be 7.5%. We would multiply by 100. Okay? So we have an example where we're finding the r value, and we have an example where we're finding the t value. Okay? I have one more example for time. If you feel comfortable, do this one on your own and then just check the answer at the end. All right. So for this one, it says Toby deposits $5,675 into a retirement account that has an 8% interest rate compounded continuously. How many years will it take for Toby to have $10,000 in his retirement account? All right, so this question is asking for how many years. We know years is t. It's compounded continuously, so we know we're going to use our PERT formula. And then what else do we know? We know deposit $5,675. There's an 8% interest rate, and we want to know how long it'll take to get $10,000. So this looks like an initial value, this looks like a final value, and then our r is here. Right? Initial, final, r. So when we substitute all that in, we get 10,000 equals 5,675. E to the, now what's my R? 8 divided by 100, which is 0.08. And I don't know my t. I'm going to be solving for t. What's step number 1? Isolate the exponent. I'm going to divide both sides by 5,675. And I've got, okay, let's do this. 10,000 divided by 5,675 is 1.76 equals e to the 0.08 times t. And now that my exponent is isolated, what can I do to both sides? Take the natural logarithm. Natural logarithm of 1.76 equals the natural logarithm of e to the 0.08t. What's next? Properties of logarithms. Good. So ln 1.676 equals, what do I do with my exponent? Slide it to the front. Times the natural log of e. And what is the natural log of e? Natural log of e is 1. So I'm just left with the natural log of 1.76 equals 0.08t. Now we're on step 4. Isolate the variable. My variable is t. I need to get t by itself. How do I do that? Divide both sides by 0.08. So I've got t equals the natural log of 1.76 divided by 0.08. So let's do that in the calculator. Step 5 is to determine an approximate answer. So I've got my 1.76 already in here. I'm going to hit the natural logarithm button, and I get 0.5665 divided by 0.08. So I'm going to divide this by 0.08, and I get 7.08 years. So t is 7.08. Sound good? Okay, so if you need to watch the video again or email me, text me, anything if you have any questions, okay? I will talk to you later. Have a good day.